Here we are at our example 3 from our 8.3, number 2 set of notes. We're asked to graph this following rational function. Now, how we normally start off with these is we try and find out what is our HA. We're going to go ahead and look for our horizontal asymptote first. And just looking at our scenario, we see that the degree on top is the exact same as the degree on the bottom. And in that event, what we're going to go ahead and do is divide those leading coefficients. Because we don't see any right here on top or bottom, we know that we're going to assume that they are 1 for both. And so when we now divide these, we end up with our horizontal asymptote being y equals 1. Next, what we're going to go ahead and do is try to factor out the top and bottom. And when we do that, we would end up with x plus 2 times x plus 3. Factoring out the bottom, we see that we have the difference of two perfect squares, and that'll break down to be x plus 2 times x minus 2. At this point, what we would normally do is we can see that we have the x plus 2 on top, 1 on bottom. They do end up dropping out. However, what we still have to do is set this bottom not equal to 0, including the item that did just cancel. Because even though we just canceled, if you did let x be negative 2 here, you would still get 0 on the bottom, and unfortunately we just can't have that. So even though he canceled, we're still going to set this bottom not equal to 0. And likewise, we're going to do that with our x minus 2, not equal to 0. So because he did cancel like that, this will become eventually our whole. And this is our vertical asymptote that we're looking for. Subtracting 2 from both sides, we end up with x cannot be negative 2, and x cannot be positive 2. So again, if we canceled out like that, that becomes a whole instead of a vertical asymptote. This x minus 2 did not cancel out at all, so he is remaining that vertical asymptote. At this point, so we've established our VA, our whole. Slant asymptote, we actually won't have any because the degree is not one more on top than it is the bottom. So for our SA, we won't have any. Also, what we can go ahead and do for this whole is go ahead and throw in that x value that we just found. We got negative 2. To find the corresponding y value, we're going to go ahead and throw that into x for our simplified version of this rational function. We're going to go ahead and find what is the y value if we throw in negative 2 into that simplified version. So it looks like our y value comes out to be 1 on top over negative 4 on the bottom. So our whole is actually going to happen at negative 2 comma negative 1/4. It's an actual coordinate point that we'll see in a moment, that it's actually a full whole instead of like an asymptote. Looking now for x-intercepts. Because we saw this cancellation happen from top and bottom, we actually lose that ability to actually have this as an x-intercept. Because again, it's going to become that whole at negative 2, negative 4. That's why I wanted to cover the whole before we went into x-intercepts. But just know that for this guy, since he crossed out, he's no longer an x-intercept. Okay. For the x-intercepts, pretty much what we're going to do is just set that top remaining item equal to 0. So pretty much just this x plus 3. The reason for that, again, is we're trying to see where is it crossing this x-axis, that x-intercept. It's happening somewhere. And right now we just don't know where that is. But we do know that every single time, if it is crossing this x-axis, that our y values are always 0. That's in fact exactly why we could say f of x or y is equal to 0. We have 0 instead of f of x is equal to pretty much what's left over, this x plus 3. Now we're just solving for x. So all we have to do is subtract 3 from both sides. So our x-intercept will come out to be -3, 0. All right, now just kind of piling all this stuff on there on the graph. We have an x-intercept that we just found at -3, 0. Go ahead and plot him. We know that we should have a hole at -2, -1/4. So right about here. And again, that's kind of a, looks to be like a half, -1/2, but, you know, the graph's only so big. But it really is -1/4. Just want to make sure you guys can see it. Looks like we have a vertical asymptote at +2. I keep the color thing going. Yeah, and those VAs are just like those electric fences that we can't cross over. And we also have a horizontal asymptote at y=1. So more or less, we'll do a final graph in green. We should see something like this. There's our hole. We could have found the y-intercept too. Just pretty much by plugging 0 in for x. Comes out to be -3/2, so it would actually be right about there more. You see something more like that. But on the other side, you can throw a value in here. It's going to be above that horizontal asymptote. Again, just hugging here, hugging these asymptotes. What we want to go ahead and do right now is check to see for a cross of that horizontal asymptote. Again, our horizontal asymptote is 1, so we're going to go ahead and throw that in for our y value or f of x. We have 1. Is that equal to, we're going to take our simplified version of this function. Again, because these items crossed out, we're taking the simplified version of that. We have x plus 3 over x minus 2. And we're trying to solve for x here. Multiplying both sides by that x minus 2. These end up dropping out on the right side. On the left side, we would end up with x minus 2 is equal to x plus 3. If we subtract x from both sides, here they end up dropping out. We end up with -2 is equal to 3. That is not possible. We never see that. And as a result, this will have then no cross. Typically, you would do that earlier in the problem, but I kind of knew that it wasn't going to cross. And again, you want to use that with that cross. You want to check that if it's for the simplified version of this. Okay, you don't want to do the original, because that could give you a misleading cross. In fact, if you actually do that, it would say x crosses at -2, but we can in fact see that it's a hole there. So we want to avoid using the original for that. You want to use your simplified version one. Again, though, that is our example 3 from our 8.3 number 2 set of notes.